All right, today we're going to begin to solve differential equations using direction fields or by a graphical method. And basically, this is your assignment, this entire note packet from section 9.2. So as we page through here, you're going to draw a bunch of these things. You're going to do some matching, and then you're going to actually draw solutions to differential equations. So this is your assignment. And I'm going to start just by doing a couple of these and then have you finish the rest of the packet. So slope fields or direction fields. We're supposed to draw a slope field for each of these differential equations. And again, differential equation is an equation that involves a function. Here's a function right here. And some of its derivatives. So that is a differential equation. And what we're going to do is we're going to draw the derivative, the slope. The slope of this function is equal to x plus 1. And what we're going to do at every single one of the dots on this grid is we're going to draw what the slope of the function would look like if the function went through that point. So for example, the slope is equal to x plus 1. Now what if x was negative 1? If x is negative 1, well then x plus 1 is going to be 0. And so what I'm going to do whenever x is negative 1 is I'm going to draw a small segment right here showing that the slope would be 0 if the function actually did go through that particular point. Now, what if x instead of negative 1, what if x were 0? Well, then x plus 1 is 1. And so what I want to draw is I want to draw a small segment that has a slope approximately equal to 1 through any point where x is 0. So I do the best I can. I'm kind of aiming up as if I'm aiming at that point right there. And so it's approximately going to have a slope of 1. It's going to be as close as I can do it without spending all day doing it. Instead of 0, if x were 1, we'd have a slope of 2. If x were instead of 1, if x were 2, we'd have a slope of 3. And if instead of 2, we had a x being 3, we've got a slope of 4. Now, are these really a slope of 4? Were those really a slope of 3? No, but what the grader is going to be looking for on the AP exam, and what I'm going to be looking for is, do you have the zeros in the right place? And as we work our way over this way, we get steeper and steeper slopes in the positive direction. Now let's go the other way from negative 1. Let's instead go into x is negative 2, which would mean our slope, our dy dx, would be equal to negative 1. I'm drawing something like this. And if x were to be negative 3, then I'd have a slope of negative 2. Again, the trend is that as I work my way to the left, I get steeper in the negative direction. So that's how you're going to draw a direction or a slope field. And we'll talk about how useful that may be in just a little bit. Let's do another one. Let's focus our attention on number 3. Cut down on your homework by doing some of these together. Now, the slope. The slope of this function, whatever the function is going to be x plus y. So now I've got to add together the x and y coordinates. So at 0, 0, I would have a slope of 0. But at 0, 1, I've got a slope of 1. At 0, 2, I've got a slope of 2. 0, negative 1, slope is negative 1. 0, negative 2 has a slope of negative 2. Now, this one doesn't seem as easy as the previous one. Previous one, there was a nice pattern to be seen. Well, maybe there's a pattern here too, and I think recognizing patterns is going to be important. If these guys are ever opposites of each other, we're going to have a slope of 0. Negative 1, 1. Negative 2, 2. 1, negative 1. 2, negative 2. Okay, what if well, that's along a diagonal, they're all zeros. What if I bump over one this way? What about this diagonal right here? If I'm at negative 1, 2, if I add those together, I have a slope of positive 1. We've already seen this point at a positive 1. A positive 1 right here, a positive 1, a positive 1. If I bump over again, we saw this point at a positive 2. And if I go along that diagonal, sure enough, 1 plus 1 is 2. 2, 0. Gives us a slope of 2 and a slope of 2. Move over a little bit more. Let's see, point 1, 2, that's going to have a slope of 3. 3. 3. Slope of 4. 4, slope of 5. So I recognize that it's the diagonals that have the pattern for me. Here we're going to have a slope of negative 1 all the way along this diagonal. And if we bump over one more, slope is negative 2. Slope is negative 3. Negative 4, negative 5. So again, as we find our diagonal of zeros, the grader is going to be looking for that. And what does it look like over to the right of that? What does it look like over to the left of that? What are the general trends? So we estimate these slopes as best we can. Now, when we get to the matching section, we want to know, match the slope field with the function. Okay. Let's do something like number 9. Let's try to figure out what letter is number 9. If y is equal to x squared, wouldn't the derivative dy dx be equal to 2 times whatever x is? So if x is 0, I got a slope of 0. Well, that's not this. Could be b. At 0, we have a slope of 0. If x is 1, we should see a slope of 2, and we don't. Let's see. When x is 0, slope is 0. X is 1, slope is 2. X is 2, more positive, really positive. Almost getting vertical. If x were to be negative 1, the slope would be negative 2, negative 4, negative 6, negative 8, almost vertical. Well, I'm thinking C is pretty darn good. I'll look at the rest of these. That one's no good. This one, when x is 2, we have a negative slope. That's not it. Here, F, let's see, when x is negative 1, we have a positive slope. That's not it. and doesn't have a slope of 0 at 0, doesn't have a slope of 0 at 2. Yep, I think C is going to do it. So number 9, I would say is, number 9, I would say is C. And one more that I'd like to do with you, and then I'm going to just let you work on the rest of this on your own. That's number 19. It says that the calculator, and there's actually a program you have on your calculator, but we won't have it for our purposes. But there actually is a program that you can put on your calculator that you can have it draw a slope field for you. And here we are told that the slope is already drawn for us. It's equal to x times y. All right. Now, sketch, let's see, the solution curve that passes through the point 0, 1 is shown. Now, what they've done here is this. They said, okay, we've drawn the slope field. But what would the solution look like? What would the function look like if the function went through the point 0, 1? Well, think of these slope field segments as little traffic cones, and you've got to stay within the cones. You can't run over cones. You're going to fail the driving test. So as I work my way to the right, it looks like the cones are directing me this way. And it looks like I've got to go up and up and up, and I've got to get steeper and steeper and steeper. As I work my way to the left from 0, 1, the traffic cones are directing me this way. And I would have a function that looks like this. Then it says, okay, what would you draw? Sketch the solution if you were told that the function goes to the point 0, 2. Okay? Right here in green. Well, the same thing's going to happen. As I work my way to the right, it looks like I'm being deflected upward. If I work my way to the left, again, I'm being deflected upward. I have something like that. Now, what if I were to draw the solution curve through the point x is 0 and negative 1? As I work my way to the right, traffic cones are directing me. And I'll let you finish up the other side of 19b. But that's how we can sketch a solution. We can't find a solution. That's going to come in section 9.3. We're going to actually find the equations of solutions. But here we can at least graph what the solution would look like by obeying the traffic cones that are set up by these direction fields or slope fields that we're able to draw. So finish up the rest of these prior to our next class.